Hi, this is Andrew from Black Hill Software. Today I'm going to show you how you can query CICS transaction SMF data using Java streams and the EasySMF Java API. I'll demonstrate the programs on my PC, then at the end of the video I'll show you how you can run them on the mainframe against SMF dump datasets and live logstream data. Let's get started. I've got an empty class with a main method. I'll start with a few imports for classes that I'll be using. CICS transaction SMF data uses a dictionary to refer to the fields, so first we need to read the dictionary records. I've got the dictionary records in a separate file, so I'll use the SMF110 record dictionaries from name method and supply the file name to read the dictionaries. Now I can read the transaction records. I'll create an SMF record reader using a file name and include only 110 subtype 1 records. I'll put it in a try with resources block so it will be automatically closed at the end of the block. Java Streams allows me to filter and process records in a query style with multiple steps. I'll stream records from the reader and use the map statement to create SMF110 record objects from the input SMF records. We know the records will be type 110 because I set the include statement on the reader. Now I need the transaction performance records. Each SMF record has multiple transactions, so the performance records are returned in a list. The flat map function combines the contents of the multiple lists into a stream. Now I can filter the transactions. I'll add a filter which will only accept transactions with an elapsed time greater than 1 second. Then I'll print the details of the transactions with system out print line. I'll add another filter to filter by Apple ID. We can apply this filter before we extract the performance records. Now I can run it and see the results. I can print the transaction information in different formats. EasySMF has JSON functions, so I can print the data in JSON format. I'll create a JSON instance using EasySMF JSON builder and tailor the output to remove the uninteresting stuff. Include empty strings, false. Include zero values, false. Include unset flags, false. CICS clock detail, false. And avoid scientific notation, true, to make the numbers more readable. Now I can add another map step to convert the transactions to JSON and we can see the results. If you want to load the JSON data into something like Excel, the records need to be in a single JSON array. That's easy to do. We just collect the records into a list and convert the list to JSON. Now we have a single array. It's a bit easier to see if I add pretty printing to the JSON output. Here you can see data in a JSON array format. We can also get a bit fancier writing the output rather than just print line. The for each statement can be a block of code. I'll add braces here to create the code block. For each transaction, first I'll write the transaction name, start time and elapsed time. Then I'll loop through the dictionary entries for the transactions, checking if each entry is a CICS clock field. For each clock field, I'll check the timer value, and if it's greater than 10% of the elapsed time, I'll print the field name and value. This way we can see any clock values that represent a significant portion of the elapsed time and ignore the others. I'll add a new line to finish the output line and run the program. Now we can see the long-running transactions with the significant CICS clock values. You might want to find transactions with the largest values in a particular field. EasySMF provides a top function to find the top values for a field. This function is designed to process millions of entries, so it doesn't need to sort the data or hold all values in memory. It just keeps a reference to the top values seen. I need to insert a collect statement in the stream using top values as the collector. I specify the number of entries to keep and a comparator which specifies how to compare the values. I'll specify the top 10 entries comparing by elapsed time. I can turn the collection back into a stream to generate the output. The output from top is sorted, so I'll use for each ordered to tell Java to keep the entries in order. Now we can see the top 10 transactions by elapsed time. Java streams can also group data. I can add a collector to group by the transaction field, and then for each group collect the top values by elapsed time. To make things clearer, I'll create a variable to hold the result and write the output in a separate statement. The grouping produces a map with a string key, which is the transaction name, mapped to a list of top values for that transaction. I'll change the output to process the map entries sorted by key, which is the transaction name, write a header for each entry, and then the group data. Now we can see the top 10 entries for each transaction. Let's look at a different type of query. Imagine you're investigating a problem where there was a slowdown in a CICS region and transactions were taking a long time. You know when the problem started and stopped, and you suspect that there was one transaction that caused the problem. You want to find that transaction and look at the details. The transaction must be long running and must be one of the first transactions started in the problem period, although not necessarily the very first. So we can create a query. We want to filter by Apple ID and by start time. Start time uses a zone date time, which has a slightly odd creation function. It takes values for year, month, day, hour, minute, second, nanoseconds, and a zone ID. You can actually specify your local time zone for the zone ID if you want to use local times. For example, zone ID of Australia/Melbourne, and Java will do the conversion to UTC. We'll filter the start time by before and after, and by elapsed time. I don't have many long transactions in this data, so I'll just use a value of 1 second. Now I collect the top 100 values comparing by start time. By default, comparing times will give us the latest values, but we can reverse the comparator to get the first values. Now I have the first 100 long-running transactions by start time. Java Streams provides a number of other collectors we can use. If I group the data again by transaction name, I can use collectors counting to give me the count of each transaction, sorted from highest to lowest. Or I can use summing double to sum the user CPU time values. Now let's look at running on the mainframe. Reading from a dataset is as simple as changing the name in the SMF record reader and using the dataset name syntax. If you run under the JSON batch launcher, you can also use a DD name from the JCL. Or you can read from a logstream. There's a SMF record reader builder class to help you specify the parameters for the logstream. The builder helps you add optional values for the SMF logstream exit and logger subsystem, like from and to values using local or GNT time, system ID, smart endpoint, etc. Then I build the SMF record reader. I'll create another query example. This time I'll list all the transactions from a specific terminal sorted by start time. I'll clean up some of the stuff I don't need and copy my program to a file on ZOS. Under Java 11, I can run this file directly without compiling it first. Java will automatically compile programs that are contained in a single file. I could run it under Java 8, but I would need to compile it first. I'll run the program under bpx batch. I set the environment variable pointing to the EasySMF key file in the standard env.dd. The Java shell command has the cp option to set the class path and the name of the Java file we just created. Now I can submit the job and get the output in STSF. We can see the transactions from the terminal we specified. That's how easy it is to query CICS transaction SMF data using the EasySMF Java API. Why not download a free trial and try it against your own data? See the links in the description. Don't forget to subscribe to get notifications of new videos, and thanks for watching.